Okay, I hope you had a chance to at least try this worksheet. But if not, the goal is do a couple of these with me, then pause the video and try some. You're never going to know just from copying this down if you're understanding them or not. So do as many as you need to with me, then try some on your own. That is the best way to learn trig. This is one of those topics we have to know before we go on to Math 3. Trig and the special right triangles that we're going to do next week are crucial topics for your future in higher level mathematics. Okay, so what are the steps we're going to take today? Number one, the biggest thing is identify the trig function. And which ones are we choosing between? We're choosing between sine, which is the opposite over the hypotenuse, cosine, which is the adjacent over the hypotenuse, or tangent, which is the opposite over the adjacent. So Katoa, always write that at the top of your page so you have it handy. Once we identify which trig function, you're going to set up the equation using that correct trig function, and then, of course, you're going to solve it. So these are our steps we're going to follow for this whole first page. Let's go try it out. So looking at this first angle, we've been given this angle down here of 43 degrees. In relation to this reference angle, you've got the furthest leg, also known as the opposite, and you've got the hypotenuse, which is your longest leg. So if we've got an opposite and we've got a hypotenuse, which trig function uses the ratio of the opposite over the hypotenuse? You got it. It's our sine function. So step one, identify. It's going to be a sine. Step two, set up that equation. The sine of 43 degrees is equal to the opposite over the hypotenuse. So look for a second to see if you understand where all these pieces came from. So the angle plugs in here with the word sine. And then after the equal sign goes the opposite on the numerator, and the denominator is your hypotenuse. Now we go solve. How do I solve for x here? I want to isolate this x. Well, I need to get rid of this denominator by multiplying by the 12 in order to cancel that out. So x is going to be approximately 12 times the sine of 43. So you've got to have handy your Desmos over here, where we're going to go 12 times. Now, where do I get that sine function? You click on the function tab. So you're in the main tab, you click on the function tab, and that brings you to the sine of 43. And so notice here this little toggle between radian and degrees. If you're ever getting a weird negative answer, it means you're probably in the wrong mode on your calculator. This can happen on regular calculators too. So make sure you're in the degree mode, and our answer is 8.18. And because we're finding a missing side length, it's going to be, oops, we do have a units here. It's going to be feet in this case. Do you see right here how they told us it was in feet? So my units are feet. Notice I'm using the approximation symbol because I rounded 8.18398, blah, 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 blah. We're just rounding it to 2 decimal places to the hundredths place. Every math class you take at El Camino, if they do not specify, you are going to round to the hundredths place. If they do say a different thing like tenths or thousandths, you'll do that. Okay, let's go try the next one and see if we start to get the hang of it. So this time we're given this bottom angle. In relation to this reference angle down here, you're given the furthest leg, the opposite, and the closest leg, the adjacent. So when I'm given an opposite, an opposite and an adjacent, which trig function uses the opposite and the adjacent? You got it. It's our TOA. So here I go setting up step one, identify. Step two, set up that equation. The tangent of 17 degrees is equal to the opposite over the adjacent. So the tangent of 17 degrees is equal to the opposite over the adjacent. Now I go solve, multiplying by that denominator of 29. This is what I'm actually going to go plug into Desmos. We're going to say 29 times the tangent of 17. And we get 8.87 inches. So notice I'm using the approximation symbol because I rounded, and I just multiplied 29 times the tangent of 17. Okay, let's go try the last one here. This time in relation to this angle that they gave me, I have the closest leg, there's my adjacent, and I have the longest leg, the hypotenuse. So what uses an adjacent and a hypotenuse? You got it, the cosine function. So now that we've identified that it's a cosine, we're going to set it up. The cosine of 50 degrees is equal to the adjacent over the hypotenuse. Notice this time that the x is in the denominator. When I go to multiply by the denominator, both sides are going to be times x times x. I'm bringing the x up by doing that. So I'm going to get x times the cosine of 50 is equal to 9. So we just multiplied by x by that denominator to bring it up. And now we're going to divide by the cosine of 50 to both sides to solve for the x. So this time when I go plug this into Desmos, I'm actually going to type in 9 divided by the cosine of 50. Oops. So 9, how do I get that divided or that fraction here in Desmos? I use the divided key. So 9 divided by the cosine of 50 gives us 9.00. And I look again to see what units I'm in, and I notice I have kilometers. How'd you do? So what was different on this third one is that the x was in the denominator, and we had 2 steps to solve. We had to multiply by the x to bring it up. Then we divided by the cosine of 50. Anytime you're solving for the variable in the denominator, you're going to take those 2 steps and you're going to end up dividing. Okay, let's go do a couple more. Remember I said pause the video and try it on your own. See if you can get the trig function on your own. Then see if you can at least pause there and set up the equation on your own. Then pause it again, see if you can solve it on your own. Okay, this time we've got the 70 and we've got the closest leg and the hypotenuse. Which trig function uses that adjacent leg and the hypotenuse? You got it. It's our cosine. Step 1, identify. Step 2, set up that trig equation. Cosine of 70 degrees is equal to the adjacent over the hypotenuse. Yay, the denominator has a number. Let's go multiply by that 13 to both sides. And we get x is approximately, this is going to be in millimeters, 13 times the cosine of 70. And I'm getting 4.45 millimeters. How'd you do? Awesome. Okay, here we go on the next one. Again, pausing, seeing how you do, then seeing where you get stuck. Every time you're trying to get a little further. This time it looks like they gave us, from this reference angle of 10, they gave me the furthest leg, my opposite, and my hypotenuse. Which trig function uses that opposite leg and that hypotenuse? That would be our, you got it, our sine function. So sine of 10 degrees is equal to opposite over hypotenuse. Oops, that denominator's on the bottom with the x. So this time we bring the x up. And then we divide by sine. We know when there's a denominator with the variable, we're going to end up dividing this trig function. We're going to get that x is approximately something inches. Let's go see what that comes out to. So we have 6 divided by the sine of 10 degrees. And we're getting 34.55 inches. How'd you do? Okay, here comes number 6. Our reference angle is the 34. We're given an opposite leg, the furthest leg, and we're given an adjacent leg, the closest leg. Which trig function uses an opposite and an adjacent? You got it. That's our tangent function. So tangent of 34 degrees is equal to the opposite over the adjacent. And we're going to have to multiply to bring up that x. X tangent of 34 degrees is equal to 85. And then we're going to divide by the tangent of 34 degrees to both sides. And that gives me that x is approximately, so we've got 85 divided by the tangent of 34. Oops. And we get 126.02. Do you see why I'm rounding this to 0.02? And this is going to be centimeters. Okay, how'd you do? Those first 6 problems are the first 6 trig functions I was hoping you could solve. I hope you did some of them on your own. If you didn't do any of them on your own, right now you should grab a new piece of paper and you should try 1 or 2 of them on your own and make sure you can do the trig functions by yourself.